Good day, everyone. So, guys, today we are going to be dealing with physics, motion under physics. So, whenever you hear motion, it simply means the change in position of an object from one place to another. That is to say, if I move from one place to another, what I'm actually doing is what we refer to as what? Motion. But in normal English, we can call it what? Movement. So we can simply refer motion to as what? Movement. So guys, the study of motion without considering the force causing the motion is called kinematics. So you might be wondering that what does kinematics means? Are you here? And what does dynamics means? So kinematics simply means the study of motion without considering the force causing the motion. That is how I'm moving without considering what is making me to move. That's what we mean by what? Kinematics, without considering the force causing the motion. Why dynamics simply means the study. So guys, dynamics means the study of force and how it affects the motion. So how force affects the motion is what we mean by dynamics, but the study of motion without considering the force is what we mean by what? Kinematics. Now let's talk about the parameters of kinematics. The parameters of kinematics include distance, displacement, speed, velocity, acceleration, jerk, and the rest. So let's talk about the first thing here, which is distance and displacement. You see, if you're talking about distance and displacement, if I move from one place to another, are you there? The length I covered from one particular point to another, that length is what we refer to as what? Distance. Also, if I also move from one point to another, the length I also covered is also what we refer to as what? Displacement. But what is the salient difference between distance and displacement? The salient difference between distance and displacement is that distance is a scalar quantity, while displacement is a vector quantity. Now, what do we mean by scalar and vector? Scalar quantities are quantities that has magnitude, but no direction. While vector quantities are quantities that has both magnitude and direction. So this simply means that if I should move from a particular point A to a particular point B, I'm going to say that I have covered a displacement. The reason why I'm going to refer it to as a displacement is because I moved from one particular point to another point. I know my direction. But if I just move, if I'm just, let's say something happened and everybody is running helter-skelter, you know, you won't have a destination in mind. You just be what? Running helter-skelter. Are you there? So the length you are going to cover will be referred to as what? Distance. Because what? There is no direction. But if you just move from your house to your school, the length you covered will be referred to as what? Displacement. Because you have what? You have your what? Direction. Now, guys, we are moving on to speed. Speed simply means the time rate of distance covered or distance traveled. Guys, whenever you hear something rate, it simply means something over time. So the time rate of distance traveled is speed. Then this simply means that the formula for speed will be distance over time. The formula for speed is what? Distance over time. Don't forget that the unit of distance is meter and the unit of time is second. So therefore, the unit of speed is what? Meter per second. Meter per second. Also, guys, don't forget that distance is a scalar quantity. Right? So therefore, speed is also a what? Scalar quantity. Therefore, guys, you have to know that speed is referred to as the slope of straight line distance time graph. So they ask you that, what is the slope of straight line distance time graph? The answer is what? Speed. And the reason why is because speed is equal to what? Distance over time. The next thing now is what? Velocity, guys. Velocity is the time rate of displacement covered. Time rate of displacement. So this simply means that velocity will be equal to what? Displacement over time. But speed is what? Distance over time. But distance and displacement, they have the same unit. The only thing that just differentiates the two of them is what? Is the direction. So if you're given a particular direction, you're going to be talking about what? Distance. And if you're not given a particular direction, you'll be talking about what? If you're given a particular direction, you'll be talking about what? Displacement. But if you're not given the direction, you'll be talking about what? Distance. So that is why velocity is what? Displacement over time. The unit of velocity is also what? Meter per second. But velocity is a what? Vector quantity. So unlike speed, which is scalar, velocity is what? Vector, because displacement is vector. And also velocity is the slope of displacement time graph. So if you see the question that what is the slope of distance time graph, the answer is speed. But what is the slope of displacement time graph? The answer is what? Velocity. So don't forget that speed and velocity, they also mean the same thing. But speed is scalar, while velocity is what? Vector. Distance is scalar, while velocity is what? While displacement is what? Vector. Now let's move on to acceleration, guys. Guys, we are going to move on to acceleration now. What is acceleration? Acceleration is simply the time rate of increased velocity. Acceleration is simply the time rate of increase in velocity, right? So now, this simply means that the formula for acceleration will be equals what? Increase in velocity over time. So guys, I will now ask you, what do we mean by increase in velocity? Our increase in velocity might also be referred to as change in velocity. And the formula for increase in velocity is final velocity minus initial velocity. The formula for increase in velocity is final velocity minus what? Initial velocity. What we use to represent final velocity is v. And what we use to represent initial velocity is what? Is u. Initial velocity, that is the velocity you are using to start. And the velocity you are going to use to end is what referred to as what? Final velocity. So therefore, the formula for our acceleration, which is increased velocity over time, can be written as A is equal to V minus U over T. And mathematically, we can make V the subject of the formula. Then we are going to get V is equals to U plus AT. And this equation is known as the first equation of motion. So the next thing you have to note is that the SI unit of acceleration is what? Meter per second square. Do not forget that we've talked about speed and velocity today. The unit of speed is meter per second. The unit of velocity is meter per second. They are the same units. But speed is scalar, while velocity is vector. But the unit of acceleration is what? Meter per second square. Acceleration is also a vector quantity. And acceleration is also the slope of velocity time graph. Because acceleration is velocity over time. So therefore, acceleration is the slope of velocity time graph. Then you have to know something, that if we can have increase in velocity, we should also have decrease in velocity. So the decrease, the constant or steady time rate of decrease in velocity, is what we refer to as uniform deceleration. So this simply means that increase in velocity is acceleration, while decrease in velocity is what? Deceleration. Another term we use for deceleration is what? Retardation. And you have to know that acceleration and deceleration, they have the same what? Meter is positive, while deceleration is negative. So the last thing we are going to move on to now, we are going to see that we say that acceleration, we say that velocity is the time rate of displacement, while acceleration is time rate of velocity. But you also have to know that we have what we refer to as time rate of acceleration. The time rate of acceleration is called jerk. What did I say? Jerk. J-E-R-K. That's the time rate of acceleration. And the SI unit is meter per second cube. That's it, guys. Let's move on to the next thing. We are going to be talking about speed. Average speed is defined as the time rate of total distance covered. So this simply means that the total distance all over time can be referred to as what? Average speed. So that is why the formula for average speed is called what? Total distance covered over total time taken. Now, we can also define average speed in another manner when we are considering the two velocities for an object, the initial and the final velocity. So the average speed will just be equals to the final speed plus initial speed all over 2. You know, you're talking about the average of something that is dividing by 2, right? So therefore, the average speed can be equals to what? V plus U over 2. So that is what average speed means. It has the same unit as what? Meter per second, and it is a what? Scalar quantity. Anything speed is scalar. Anything velocity is vector. So now, instantaneous speed and velocity. We can also have what we refer to as instantaneous speed and velocity. Instantaneous speed is, whenever you hear something instantaneous, it simply means at a particular time, at any time. Right there. So if it is instantaneous speed, it is a speed at any instant in time. And if it is instantaneous velocity, It is the velocity at any instant in time. So the speed at any instant in time is referred to as what? Instantaneous speed. Why the velocity at any instant in time is referred to as what? Instantaneous velocity. So therefore, you have to know something, that whenever you want to calculate the instantaneous speed, either or the instantaneous velocity, we usually differentiate. What do we do? We differentiate. So you have to know that velocity is the what? Is the first derivative of displacement. While acceleration is the second derivative of displacement. But you know, the reason why velocity is the first derivative of displacement is because velocity is what? Displacement over time. But you know that acceleration is velocity over time. So that is why acceleration will be the second derivative of displacement. But you know, acceleration is also velocity over time, right? So we can also say that acceleration is first derivative of velocity. So that is why whenever you want to calculate your instantaneous speed or your instantaneous velocity, we are going to be differentiating. That is why we wrote V is equals to ds over dt. That is a differentiating displacement all over what? Time. So instantaneous speed is a scalar quantity and the unit is what? Meter per second. But instantaneous velocity is vector and the unit is also what? Meter per second. So you have to know that the instantaneous speed can also be referred to as actual speed. While also instantaneous velocity can also be referred to as what? Actual velocity. Do you get that? So that's that, guys. Let's move on to uniform speed. Guys, if you're talking about uniform speed simply means the time rates of equal distance moved in equal time. The SI unit is meter per second. It is a scalar quantity. It can also be referred to as constant. This simply means that another term for uniform is what? Constant. So guys, if you're talking about uniform velocity, it is the time rate of equal displacement in equal time interval. So this simply means that uniform speed is the time rate of equal distance in equal time. But uniform velocity is time rate of equal displacement in equal time. Do you get that? So this simply means that if you are moving from one point to another, either, and you are covering equal distance in equal time, we are going to say that your movement is constant or your movement is uniform. So for uniform velocity, the final velocity would equals to the initial velocity. Why? Because you know we say we are moving equal distance, equal time. This simply means that the velocity you are using to start will also be the same velocity you are using to end. Right there? So we are talking about equal movement. Let's say you are to move from this point to this point. Let's say this is point A. This point is point B. This point is point C. This point is point D. Let's say the distance from here to here is 2. Here to here is 2 meters. Just for example, guys, here to here is also 2 meters. Now, the distance, when you move from this point to this point, you move at, let's say, you move at 2 seconds. You also move from this point to this point, you move at another 2 seconds. You also move from this point to this point, you also move at another 2 seconds. This simply means that you are covering equal displacements in equal time. Equal displacement in equal time. You're going to say that the displacement from A to B is the same as B to C, is the same as C to D. While also the time for A to B is the same as B to C, is also the same as what? C to D. That's what we mean by what? Equal displacement in equal time. So that type of velocity is referred to as what? Uniform velocity. Do you get that? So it is a vector quantity and the unit is meter per second. And you have to note that the acceleration of a body moving with uniform velocity would be 0. The acceleration of a body moving with uniform velocity will be 0. Why? Because acceleration is the time rate of increase in velocity. But when an object moves with uniform velocity, it moves with equal distance, equal displacement in equal time. So if an object moves with uniform velocity, this simply means that the velocity is constant. The velocity is not changing. So there is no increase or decrease in velocity when we are talking about what? Uniform velocity. the velocity is constant. The final velocity is equal to the initial velocity. So that is why the acceleration of an object moving with uniform velocity would be what? 0, because there is no increase in velocity. And acceleration simply means the increase in velocity per time. Do you get that? That is all. Let's move on to the next thing. Instantaneous acceleration. Okay, guys. So instantaneous acceleration simply means the increase in velocity at any instant in time. So if you want to calculate the instantaneous acceleration, it will be dv over dt. That is to say, you are going to differentiate velocity with time. Do you get that? You are going to differentiate velocity with time because instantaneous acceleration simply means velocity over time. But in some scenario, you might be given the displacement and you were asked to calculate the instantaneous acceleration. Since you've already known that acceleration is the second derivative of displacement, so in that case, if you are given the displacement and you have to calculate the acceleration, then the formula for your acceleration A will be equals to d square x over dt square. This x represents the what? The displacement. So if what we are given is velocity, the acceleration will be dv over dt. But if what we are given is displacement, the acceleration will be d square x over dt square. Then before I move on to some examples, you have to know that we have an instrument known as speedometer. Speedometer is used to measure instantaneous speed. We have an instrument we know as odometer. It is used to measure distance travel. Odometer is used to measure distance travel. And we also have an instrument we call tachometer. Tachometer is used to measure the rotation speed of a shaft or disc. It measures the revolution per minute, RPM, of a moving object. So let's look at some example, guys. So guys, in this example, the question is a car moves with a speed of 30 meters per second. Calculate the distance traveled in 30 seconds. Guys, whenever you have a physics question, the first thing you should do is to write all the parameters. What are what? The parameters. So they say the speed is 30 meters per second. That's why V is equals to 30 meters per second. That's the speed. So calculate the distance traveled. What are we looking for, guys? Distance. So we're going to say that the distance is equal to question mark in 30 seconds. That simply means the time. T is 30 seconds. Therefore, you are going to use velocity is equals to distance over time. Velocity is 30 is equals to distance over time. And the time is also what? 30. And the final answer for the distance would be equals to 900 meters. So this is the final answer for the question. So guys, in this example, the question is an object of mass 4 kg. Write the mass M is equals to 4 kg. Moves with a uniform velocity of 20 meters per second. The velocity is 20 meters per second. Calculate the magnitude of its acceleration. We are looking for a question mark. After 10 seconds, the time is what? 10 seconds. So guys, in this particular question, what we are looking for is the what? Acceleration. Since we are looking for the acceleration, we don't need to consider this mass. So what we just do now is that you just remember that acceleration is equal to velocity over time. Since our velocity is 20 meters per second and our time is 10 seconds, then the final answer for the acceleration will be what? 2 meters per second squared. So that is that about that, guys. Okay, guys, in this particular example, a man covers the first 240 meters of his journey at 4 meters per second. So I can say that the first distance d1 is equals to 240 meters. The velocity v1 is equals to 4 meters per second, because they say that the first 240 meters, meter is the unit of distance, and the second 40 meters is equals to 240 meters, and then v2 is equals to 10 meters per second. The second distance and the speed. Complete is average velocity. So I'm looking for average velocity. So guys, you know, if you're talking about average velocity, that simply means total distance all over total time taken, right? So I don't have any problem. So what I will just look for is that I will look for my total distance. I will also look for my what? Total time taken. So guys, the total distance would equals to d1 plus d2, and that's equals to 240 plus 240, and that's equals to 280 meters. This is total distance, guys. Now what remains? It remains the total time. Now if I want to get my total time, this simply means that I will just remember that velocity is equals to distance over time. So I'm going to look for the first time, t1, right? So I'm going to say v1 is equals to d1 over t1. My v1 is 4. That will be 4 is equals to d1 is 240 all over t1. Then my t1 will be equals to 240 over 4. Then this will be equals to 60 seconds. I will also calculate for my T2. I will say V2 is equals to D2 over T2. So that will be V2 is 10 is equals to D2 is what? Is 240 all over T2. Then T2 will be equals to 240 over 10, and that's equals to 24. So therefore, guys, I can get my total time taking to be equals to T1 plus T2. And that's equals to 60 plus 24. And that's equals to what? 84 seconds. So therefore, average velocity, distance, all over total. Guys, please. That will equals 480 meter all over 84 seconds. That is what? Meter per second. So that is that. Let's go. Position of a particle is given by x equals 3 minus 2t plus 3t squared. Right solution. The equation given to us in the question right now, x is equals to minus 2t. Now the first question is that we should calculate the instantaneous velocity and acceleration at t is equal to 3 meters per second. 3 seconds. Whenever they are going to give you a question, basically under instantaneous velocity or instantaneous acceleration, it will be given to you in this equation form like this. So you will now listen and listen attentively, guys. The equation given to us in the question is this. Guys, you have to firstly know something. If you are calculating the instantaneous velocity, you have to do dx over dt. Your instantaneous velocity is equals to dx over dt. While instantaneous acceleration is equals to dv over dt, or a is equals to d square x over dt squared. So guys, listen attentively. So you have to firstly be able to identify the parameters. What is x representing? Basically, x represents displacement. What is t representing? Time. This simply means that if I should differentiate this x with respect to this t, that simply means that I'm differentiating displacement with respect to time. The answer I'm going to get will be what? Velocity. So that is why your v is equals to what? Dx over dt. So therefore, guys, if I want to do my instantaneous velocity, I will just use this formula. But now, if I want to do my instantaneous acceleration, I'm supposed to do dv over dt. But I have two formulas for instantaneous acceleration. The first one is dv over dt, while the second one is d square x over dt square. If what is here is x, and you are to do instantaneous acceleration, you are going to use the formula a is equals to d square x over dt square. But let's say that it's a different question, and you are to do instantaneous acceleration a, then you are going to do dv over dt. Do you get that, guys? So that is that. Now let's firstly do the first one, instantaneous velocity. That will be dx over dt. So I'm going to differentiate this equation. Now, I know most of you are not used to differentiation, but listen, the first hint you need to know now is that the differentiation of a constant number would always be 0. So this simply means that even if you don't know how to differentiate, this 3 is a constant number. So the differentiation of this 3 would give us what? 0. That is done. Now, another hint is that whenever you are differentiating, you are going to be dealing with the power of x or t or any variable in the question. Whenever you are differentiating, you are going to be dealing with the power. So how many things are you going to be doing with the power? You are going to be doing two things with the power. You will firstly use the power to multiply the coefficient, and you will secondly minus 1 from the power. Everybody, whenever you are differentiating, you are going to be dealing with the what? Power. You are going to be doing two things with the power. You will firstly use the power to multiply the coefficient, and you will secondly minus 1 from the power. This simply means that, let's just say that I want to differentiate 3t squared. I want to differentiate 3t squared. What am I going to do? I'm going to be dealing with the power. What is the power here? The power here is 2. So how many things will I be doing with the power? 2. I will firstly use the power to multiply the coefficient. What is 2 times 3? That will be 2 times 3t. And the second thing I'm going to do with the power is that I'm going to minus 1 from the power. I'm going to write 2 minus 1. That's it. So the final answer for this will now be what? 60. Do you get that? So therefore, I've told you that the differential of a constant number is what? Is 0. So the differential of 3, that is 0. Minus. Now I'm going to differentiate 2t. Everybody, what is the power of t in this 2t? That is 1. Because anything else power 1 is that. So the power of t here is 1. So therefore, I'm going to use that 1 to multiply the coefficients. What is 1 times 2? That is what? 2. You know, after that, I will now minus 1 from that power. Everybody, what is 1 minus 1? That is what? 0. What is anything else power 0? Anything else power 0 is what? Is 1. So this simply means that the differentiation of 2t is what? Is 2. Do you get that? And the differentiation of 3t squared, that will be what? 60. The power is 2. Use this 2 to multiply the coefficient. That is 6. Then minus 1 from this power. 2 minus 1. 1. So that is. This simply means that. So guys, I will now say, the question says we should calculate the instantaneous velocity and acceleration at t is equals to 3 seconds. Right there. I will now say that at t equals 3 seconds, instantaneous velocity IV would equals to minus 2 plus 6 times 3. So what is 6 times 3? That is 18. Minus 2 times plus 18, that is what? 16 meter per second. So this simply means that my instantaneous velocity at t is equals to 3 seconds is 16 meter per second. Now, don't forget that. What is it? Is it x? If it is x, I'm going to use this. If it is v, I'm going to use this. Since it is x, I'm going to use this. So instantaneous acceleration. So that will be d square x over dt squared. So guys, what does this square means? It simply means second derivative. And how do we get our second derivative? We are going to get a second derivative by firstly differentiating. Any answer we get after the first derivative, we are going to differentiate that thing again. So this simply means that if I want to do this d square x over dt square, I am to differentiate this one twice. I will firstly differentiate. Any result I get, I'm going to differentiate that result again. So therefore, guys, so I'm going to differentiate this first. You will see that the differentiation of this one give me this. Are you there? I will now differentiate this one again. Are you there? So the differentiation of 0 will still be 0. Don't forget, the differentiation of a constant number will always be what? 0. So the differentiation of 2 will also be what? 0. But the differentiation of 60 will be what? Will be 6. So the answer for my instantaneous acceleration is what? 6 meter per second square. So the answer is 6 meter per second square. But they say that I should calculate it at t is equals to 3 seconds. If after I do the second derivative, I have t here, I would have substituted the t inside it. But since there is no t, that is why my answer will be what? 6 meter per second square. Guys, the last question is that at what time is the particle at rest? At what time will the particle be at rest? Anybody, when something is at rest, is that thing moving? No. And when something is not moving, this simply means that the thing has no velocity. So this simply means that the particle will be at rest when the velocity equals 0. So we're going to say that the particle will be at rest when the velocity equals 0. That is to say, dx over dt equals 0. So the particle will be at rest when dx over dt equals 0. So guys, you know I've done my dx over dt to be equals to minus 2 plus 60. Therefore, that will be minus 2 plus 60 is equals to 0. I'm going to make this minus 2 to the other side. That will be 60 is equals to 2 here 1, 2 here 3. And the final answer is equals to 0.33 second. So guys, this simply means that the particle will be at rest at what? 0.33 second. Thank you guys for watching. In our next tutorial video, we are going to be talking about equation of motion.